Learn it fast, learn it smart, learn with us at SOFO. Subscribe now for more videos. Contact us for on-demand and regular tuition classes.
Hello and welcome to Concept Videos from SOFO Learning. The topic today is HCF and Division Lemma, also known as Division Algorithm. Now, let's think about a simple mathematical operation around division. Let's say x and y are two numbers. X is greater than y. Now, let's say that the standard division applies here, x divided by y. Now, we will get a quotient, or we will get a quotient and a remainder. Now, how do we represent this as a mathematical equation? Here it is. X is equal to y multiplied by q plus r. Now, there are two possibilities. R could be equal to 0, which is this case, and r is greater than 0, which is this particular case. Now, let us look at the case where r is in fact equal to 0. So then this term goes away and we get the equation as x equal to y times q. Now, our goal is to think about the HCF of these two numbers, x and y. So what is the HCF of x and y? To figure that out, let's look at these two numbers, x and y. We know that y is a factor of x because x divided by y is a perfect division, there is no remainder. Now, we know that y is a factor of x and y is a factor of y itself. Now, we know that y is the biggest factor of y. It can't be larger than that. Y is a factor of x, and therefore y happens to be the biggest common factor between x and y. There is no bigger factor that could be common between these two. So therefore, y is the HCF between these two numbers, x and y. Let's now consider the case where r is greater than 0. Now remember, the equation is x is equal to y multiplied by q plus r. This r is greater than 0. Now let's just imagine that the HCF of these two numbers, x and y, is actually h. What this means is that this h is a factor of x. It is actually the highest common factor of x and y. So x divided by h should be a perfect division without any decimal point or remainder. In the same way, y times q by h. So if you divide this side of the equation by h, you got to do h on both sides, so plus r by h as well. Now this has no decimal point. This will not have a decimal point either because h is a factor of y as well. So then this factor r by h cannot have any decimal point or remainder. This h must be a factor of r as well. In other words, x by h is a whole number. This y times q by h is a whole number. So r by h will be a whole number as well. So this is a very important point. The HCF of x and y, this formula, this method or this idea shows that the HCF of x and y is also the HCF of x, y and r. Now we can simplify this. Instead of looking at more larger numbers like x and y, we can focus on these smaller numbers, y and r. So this is equal to the HCF of y and r also. So this helps us to calculate with smaller and smaller numbers as we repeat through the various y's and r's. Let's express that or explain that through an example. Let's say x is equal to 455, y is equal to 40. Now let's apply this to the equation. 455 is equal to 40 times, we have to find the q by long division. So 455 divided by 40, so you're going to get 1, you're going to get 40, 55, and then 1 here, and then you are going to get 40, and that leaves us with 15 right here. So what we have here is this 11 in here plus this 15 in here. Now we got three numbers here, x, y, and r. The x is 455, y is 40, and r is 15. So now we got to think about the HCF of y and r, which is this 40 and this 15. So let's try that. 40 is equal to 15 times, let's do it in our head, 2 makes it 30 plus 10. So the next step is to think about the new y and the new r, which is this 15 and this 10. So 15 is equal to 10 times 1 plus 5. And then we have the final step, which is 10 is equal to 5 times 2. Now this is actually 5 times 2 plus 0. So since r is equal to 0, by the earlier theorem that we learned, this 5 is actually the HCF from this step, and by extension through this theory that we are learning, it is the HCF of all these number combinations. So let's write that down very clearly, right? So what we have from this step is that the HCF of 10 and 5 is 5. Then the HCF of 15 and 10 is also 5. In the same way, HCF of 40 and 15 is 5. And finally, the HCF of this 455 and 40 is also 5. So let's review the three key points that we want to learn. First is the standard division model looks like x equal to y times q plus r. Now there are two possibilities. If r is equal to 0, then the HCF of x and y is y, assuming we have x greater than y. Alright? If r greater than 0, then HCF of x and y, you need to apply the division lemma. Alright? Now, how do we apply the division lemma? The concept here is the HCF of x and y is equal to the HCF of x, y, and r. And that is the same as HCF of y and r, and we iterate through these two steps in order to find the HCF ultimately. Thank you.